Hello students, hope everybody's doing well. Today's lesson is called Paired Samples. It matches up with chapter 24 in your textbook. Let's get started. Do anti-lock brakes work? I think we know they do, but how would we experiment with that to make sure? Well, let's have 4 vehicles. Each vehicle will go exactly 20 miles an hour on ice. The vehicle will slam on the brakes. We will measure the stopping distance, the braking distance. We will measure it with the anti-lock brakes on and with the anti-lock brakes disabled. So let's say that was done, and here were our results. So vehicle 1 slid this far with the anti-lock brakes on and slid this far with the anti-lock brakes off. And there's the results for all 4 vehicles. Is there a significant difference? You might be tempted to do a two independent sample t-test, but one of the conditions to do that is that the 2 groups are independent. Is this the case here? Think about it. Do we have a natural pairing, or do we have 2 completely independent sets of 4? I think you see that we have a natural pairing here. Vehicle 1 was done with and without. Vehicle 2 was done with and without. These are not independent of each other. They are matched, or they are paired by the vehicle. So we cannot do a 2-sample t-test. They are not independent groups. And there you go. That was vehicle 1, I believe. Yep, there it is. So what do we do now then? Well, since we can form pairs, and we want to find out if there is a significant difference between the brake lengths, we should actually go ahead and subtract and find the differences, forming one sample. So it looks like this. Now I chose to subtract x2 minus x1 only because I wanted positive numbers. You could have just as easily subtracted x1 minus x2 and get 4 negative numbers here. Note that these could be negative or positive and a mixture of both. It just so happens that each of our 4 vehicles slid longer with the anti-lock brakes off. So when I subtracted, I got 4 positive numbers. This forms the data set that you're going to be using in your test. We're actually done using these 8 numbers. We are looking for the differences of each pair. So these 4 numbers, that's our data set. Now you're first going to want to find the mean and your standard deviation, as usual, of your data set. And there's your results for those 2. Now what's next? Well, we always assume what to be true in a hypothesis test. You start by assuming give you 2 seconds, the null hypothesis is true. And the null always means no difference. So therefore, this is what the HO and the HA is going to look like for this type of test. Back to a 1-sample test. So we don't have 2 different population values here we're comparing. We're comparing 1 population, just the differences, the mean of our differences, we're comparing it to 0. Because the null is assuming there's no difference in anti-lock brakes. We would then choose our alternative based on the situation. In our case, we would be choosing greater than 0. Because we chose to subtract the way we did, we're expecting positive numbers. We expected the braking distance to be longer without the anti-lock brakes on, so the difference should be positive, we're expecting. So in this particular case, you're going to choose mu of the differences is greater than 0. Now, of course, the question is 10.75, which was our difference, our mean difference, is that significantly far from 0? Is that strong enough evidence to reject the null? Of course, it's hard to answer that question without using some probability. And here's where the probability comes in. We are now, because we're using quantitative data, we're now doing t-scores, remember. We're not doing a z-score here. We're using the t-distribution. And it's the same as usual with different letters. It's always going to be your sample minus your population, which is 0 in this case. We're assuming there's no difference, divided by the standard deviation of your sampling distribution. Here's the formula for that. It's not just the standard deviation of the four numbers. It's the standard deviation of your data set divided by the square root of n. That means that's because we're on a sampling distribution. And degrees of freedom in this case is going to be n minus 1, number of pairs minus 1. So our degrees of freedom is only going to be 4 minus 1. Then, of course, you will take that t value and you will do TCDF on your calculators, or you can use StatCrunch, but you're going to do TCDF to find the p-value. And the p-value will help you make your final decision whether anti-lock brakes made a significant difference or not. We are hopefully getting used to checking conditions. We cannot trust our results until we can check our conditions and reasonably check them off. The conditions here are pretty similar. We need a random sample. Hopefully our 4 vehicles were 4 random vehicles, or at least representative. We need to randomization. This comes from the matched pairs experiment. We should randomly assign some of the vehicles to go with the anti-lock brakes first, and the other vehicles to slide without the anti-lock brakes first, and then go the other route. And we need the nearly normal condition. We need to know that our sample is nearly normal or from a population that's normally distributed. So we can check a histogram of our data to check that out. All right, so a quick review here of when do we use the 2 independent samples t-test and when do we use the paired samples. Well, the paired samples, if you can reasonably decide that there's a matched pair or a natural pairing that forms from each point to the other point in the other group, then we'd have to use a paired sample. If we have 2 completely independent sets of data with no connection between them, then we'd use 2 independent sample t-test. How can we characterize them? Well, a 2 independent samples t-test, would that be the mean of the differences? Would we be comparing the mean of the differences? Or are we comparing the difference of the means? I'm going to give you a couple seconds. Which one goes where? Yes, a 2 independent samples t-test can be classified as the difference of the 2 different means. But the paired samples t-test is actually going to find the differences first, and we're going to test on the mean of the differences. Good luck with your work. I will see you guys soon.